You have heard about load testing. Maybe your tech lead mentioned it in a retrospective after a production incident. Maybe you saw it in a job description and made a mental note to learn it someday. Maybe you have been told explicitly that your team should be doing it and nobody has ever shown you how. That ends today. In this episode, you are going to go from zero to a working load test. We are going to install K6 together, write a complete test script from scratch, run it against a real endpoint, and walk through the output line by line so you understand exactly what you are looking at. By the time this episode is over, you will have a working load test that you can point at any HTTP endpoint and get real data from. No prior experience with performance testing is required. If you understand what an HTTP request is and you have written any JavaScript at all, you have everything you need to follow along. The barrier to entry here is much lower than most people expect, and I want to prove that to you right now. Installing K6 is refreshingly simple compared to most testing tools. K6 is distributed as a single binary with no runtime dependencies. There is no node.js to install, no virtual environment to set up, no package manager conflicts to debug. On Windows, the easiest path is the Windows Package Manager. Open your terminal and run wingit install K6. On Mac, it is brew install K6. On Linux, the K6 documentation has package repository instructions for Debian, Ubuntu, Fedora, and most other common distros. It is a straightforward apt or yum install. If you want the absolute simplest option on any platform, you can also download a pre-built binary directly from the K6 releases page on GitHub and drop it somewhere on your path. Once you have installed it, run K6 version in your terminal. You should see output like K6 version 0.50.0 or similar with the version number. That confirms the installation worked. You are now ready to write your first test. This whole process should take under 2 minutes. A K6 script is a JavaScript file with a default export function. Let me walk you through writing one from scratch. Create a new file called loadtest.js. At the very top, add 2 import statements. Import HTTP from K6/HTTP, this gives you the HTTP client. Import check from K6, this gives you the assertion helper. Now write your default export function. This is the function K6 will call for every virtual user on every iteration of the test. Inside the function, call http.get with the URL you want to test. Store the result in a variable called response. Then call check with the response in an object where the key is a description of what you are checking and the value is a function that returns true if the check passes. Check that response.status equals 200. That is it. That is a complete, valid, working load test. It makes a GET request to your target URL, and it asserts that the server responds with a 200 status code. This sounds simple, and it is, but this pattern is the foundation that everything else in load testing builds on. Every more complex scenario you will ever write is an extension of this basic structure. To run your script, open your terminal in the same directory as loadtest.js and type K6 run loadtest.js. By default, K6 runs with one virtual user for one iteration. This is actually useful as a smoke test. It verifies your script syntax is correct and your target URL is reachable before you throw any real load at it. Once you have confirmed the script runs cleanly, you want to add options to control the load level. You have 2 ways to do this. The first is command line flags, K6 run boost 10 duration 30s loadtest.js. That runs 10 virtual users continuously for 30 seconds. The second and better way is to define options inside your script as an exported constant called options. Set boost to 10 and duration to 30s as properties of that object. Putting options in the script file is better practice because the options are version controlled alongside the script. When someone checks out your repository 6 months from now, they can see exactly how the test was configured just by reading the file. They do not have to remember or document the command line flags separately. For anything beyond a quick one-off test, always put your options in the script. When your test finishes, K6 prints a summary to the terminal. Let me walk you through the most important lines. HTTP_REQ_duration is your response time metric. You will see min, median, average, max, and percentile values. Ignore the average. Focus on P90 and P95. These tell you what the slowest 10 and 5% of requests experienced. HTTP_REQ_failed shows the percentage of requests that returned an error, anything outside the 2xx range, or a network failure like a connection timeout. You want this number to be 0 or as close to 0 as possible. HTTP_X shows the total number of requests made and the requests per second rate. This is your throughput. Views shows how many virtual users were active. Iterations shows the total number of times your default function ran across all virtual users for the entire test duration. When you are evaluating results, here is a simple starting benchmark. If P95 response time is under 500 milliseconds and error rate is 0, your system is handling that load level well. If P95 is climbing above 1 second, or if errors are appearing, you have found something worth investigating. You just ran your first load test. Seriously, take a moment to appreciate what you did. You installed a professional-grade load testing tool, wrote a script that simulates real concurrent users hitting a real endpoint, ran it, and read the output. That is further than a large percentage of QA engineers working today have ever gotten with performance testing. Most of them have read about it, maybe watched a conference talk, but never actually run one. You have. From here, everything else in load testing is an extension of what you just learned. The structure of the script, the options object, the output metrics, those are the foundation that all more advanced K6 work builds on. In the next episode, we are going to go significantly deeper on reading and interpreting results. We will cover why averages lie and why percentiles are the only honest representation of user experience, how to identify the saturation point where your system starts breaking down, how to distinguish between different types of errors and what causes each one, and how to use K6 thresholds to automate pass/fail decisions so you never have to manually interpret a result again. Subscribe so you do not miss it, and if you ran into any issues following along, drop them in the comments below. Now that you have a working script, let me show you how to make it more realistic and more useful for actual testing. The basic script we wrote tests a single static endpoint. Real user behavior is more complex than that. Users typically hit multiple endpoints in sequence. They might log in, browse a list, view a detail page, and then submit a form. You can model this in K6 by adding multiple http.get or http.post calls inside your default function, with a sleep call between them to simulate think time, the time a real user spends reading the page before their next action. Import sleep from K6 and call sleep with a value between 1 and 3 seconds between your HTTP calls. This makes your virtual user behavior much more realistic, because a real user does not send 50 requests per second, they spend time looking at the screen between actions. Without think time, your test generates unrealistically high throughput per user and can make your results misleading. Adding even a 1-second sleep between calls will dramatically change how many requests per second your test generates and how many virtual users you need to simulate your actual traffic level. This is a small change with a big impact on the realism of your test results.